What? Hey, here's number 9 in section. Which section is this again?
310.
It's 310.
Okay. Just in case you're not here yet, you can look at it, and now it's going away. All right. So which one, number 6?
Yes.
All right. So this is the one where we knew that one equation was, I keep forgetting what that number is, 46.99?
Yes.
So either you just straight up buy the boxes of diapers with no discount, or you get that, what was it, 37.59?
Mm-hmm.
But you have to pay $99 to get that discount.
Yes.
All right. And like we said earlier, I know that C is 46.99. So let me just put that there.
Mm-hmm.
And I solve.
Okay, so that's where I'm getting confused because there's an X on each side, and I'm like, my brain is like, what?
Watch. No, what's happening is the numbers. How would you solve this equation over here? What would you do?
I would add 3 first and then divide. I don't know. Honestly.
Take a deep breath. I have a colleague that does yoga breathing with their students because it helps out a lot. So what do we do? Somebody tell me, what do I do when there's X's on both sides? Don't I want them all on one side? Isn't that the goal? So how would I move these over there? What would I do?
Back to the 2.
Subtract 2x so I can get my X's together, and they disappear on that side so the numbers can be by themselves, right? That's all they want. Numbers just want to be by themselves, please. Right? And then we keep going, 3x equals 3, and then we divide. So here, I thought maybe it was the kind of grosser numbers that were getting in the way, but I have something X's and I have something X's and I have the number wants to be by itself. So I got to get those the hell over there. And I do it the exact same way. Right? If I subtract them away from both sides, then the X's are on one side and the numbers on the other. Is that all right?
Yes, thank you.
I'm pretty sure the numbers got in your head and didn't let you remember what to do, right? But the numbers that are there don't mean shit. They don't mean shit, right? They don't. I know I want to get my X's together, so I do it. I don't care how ugly those numbers are. I just do. All right. Anybody else? Any other questions, guys? I'm going to suggest something because this semester, considering the situation we're in, I'm trying this new thing out. It's called being nice. I don't really, it makes me feel a little icky, but I'm still trying it out. So let me see how this feels. What if we move the quiz to tomorrow?
Yeah.
You guys like that?
That'd be awesome.
Okay. It's weird. It's foreign to me. I'm a math teacher. I took being an asshole class and I got the highest grade. And I feel like I need to write a letter to my teacher from that class and say, I'm so sorry. I am not upholding the ways of the math teacher. I feel icky. All right. But anyway, I'll stop. I'm sorry. That's all a joke, obviously. But yeah, I get this feeling that some of you guys are not really up to date on the homework and you're going to die on the quiz if that's true. Also, I just have been so freaking busy. I graded as much as I could this weekend, but then some people have turned in some stuff since then and I haven't graded anything this week. It's been crazy. So hopefully today I can somewhere find some time to grade some more of your homework so you have that to look at before you take the quiz. So let me go right now and change the date on the quiz in Canvas because otherwise I'll completely forget. And let me see. So you guys just hang out there for a second. Bum, bum. If you're just coming in, the big news is the quiz is being moved to tomorrow. Okay, I guess that was somebody saying yay. I don't know what that was. Let me see. Give me a minute here. Let me move all this stuff. Bam. So now I can make it do the next day. Let's say, well, let's see. We might as well continue being nice. Going down that path. Did I disappear there for a minute? Is that what just happened? All right, that's exciting. I checked my Wi-Fi and it was fine. You guys probably didn't hear me, and that's fine. I was just saying, I was just mumbling stuff about, hang on, let me change this other thing. All right, let's see. So if you just logged in, the quiz will now be tomorrow, and it will be due Friday. And it will still cover 3.8 through 4.2. Let me highlight myself. There, bam. Okay, any other questions from homework or anything in general? See, math teachers can be reasonable, or just teachers in general. Not all of them. Trust me, I know that. But if you don't, nobody suggested it. I just, kind of like picked up on the fact that I think a lot of you guys are not up to date with your homework. So giving you a quiz right now doesn't really make sense. So I'll move it back one day. That's it. Don't push it. Anything else, guys? Anything else from homework or anything? Okay, really? All right, all right. Let me see. So we left
Could you
off.
please, Professor, a little bit review in section 3.10, please?
I need you to be a little more specific.
Can you please review section 3.10?
All right. Okay. Let's see. All right. I'll do one problem that's related to 310. Oh. Give me a minute. Let's see. Oh, where did I go? There I am. Get up there. Okay. Oh, it's right here. Ha, 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 ha. All right, guys. So here's a very classic kind of problem. Let's say that 3 hot dogs and 2 Cokes cost, let's see. You can do it, Jeff. Let me write something over here for a second. Sure, I like it. $6.50. You can do it, Jeff. 4 hot dogs and 1 Coke costs what, Jeff? $7, I think. Is that right? You guys don't know. We'll find out. We'll see if I made a good set of equations. Find the price of each. Find the price of one of each. Price of a hot dog and a Coke. And the price of a Coke. Okay, so what are my two unknowns that I need to give variables to? What are my two unknowns? What are the two things I don't know in this problem?
Price per hot dog and price per Coke.
Yeah, go to the question. Go to the question. And that's, of course, what you don't know, because that's what they're asking you to find. So what are you going to call the price of a hot dog? Somebody give me a letter for that.
H.
No way. All right. And what about the price of a Coke?
Z.
I love it. That's so funny. I was thinking to myself, I don't know if I'm pretty sure you just said Z, or did you say C?
Yes, Z. Zulu.
All right, whatever. So I was kind of hoping somebody would give me not a C, but all right. It doesn't matter. Let's go ahead and call it C. What the shit? It kind of makes sense. Make your variable related to the actual physical thing it denotes, right? Because we have complete control over what we call our variables. So what's one equation I can set up? Look at this first sentence.
H plus C equals 650.
But that, if you said H plus C, that's one hot dog and one Coke. That's not what it says.
3H plus 2.
There we go. 3 of these plus 2 of these is 650. So of course, what's the second equation?
4H and C plus C.
4 of these plus 1 of these is $7. I don't need to put the bucks. Does somebody have a suggestion as to a good way to solve this system of equations? There's 2 algebraic ways to do this. I'm going to erase this. We don't need this anymore. Give myself some more room here. Anybody? What are the 2 algebraic ways to solve system of equations?
Substitution.
Substitution.
Elimination.
Elimination. Kick ass. So it's one thing to remember the words. Do you remember the process? Right? So either way would work here. I love elimination because it's directly killing people, right? That didn't come out right. Sorry. It's directly killing variables. All right. I'm not Dexter. I don't put plastic down on my back rim. So let's try that way first. So watch this. If I take the first equation, but in the second equation, let me see if you guys, do you remember, like right now, if I add these together, does any variable cancel if I add these together right now? If I add these equations together right now, does anything cancel?
No.
No, so I'm not going to do that shit. I wish what was here, so it would cancel with this. What do I wish was here?
A 2.
Not just a 2, because that would make 4. What kind
Negative.
of 2?
Negative.
Negative. So let me multiply this whole thing by -2. That's completely legal to do that, right? I can multiply both sides of any equation in the universe by anything I want to except 0. So if I multiply by -2, I'll get -8h minus 2c equals 14, -14. Now if I add these together, these will cancel. 3h minus 8h is -5h. 650 minus 14 is 750, I believe. Negative. Let me stop for a minute. Does this seem familiar now? I'm going to do it the other way too, in case you don't like elimination as much as I do. And then, of course, last thing I've got to do is what?
Divide 5, -5.
Yeah. So what's a hot dog cost?
$1.50.
$1.50 for a hot dog. So how would I figure out how much a Coke costs?
Plug in $1.50.
Yeah, I would take this equation and I would plug in, because now I know H is 1.5, 150. So I'm going to plug 150 in there. And the reason I picked this equation is I have one step and I solve for C, right? 4 times $1.50 is 6. So if I subtract 6, I get C is 1. So cost of a Coke is $1 for a Coke. Phew. All right, so that's elimination, where you multiply one or both equations by something that makes one of the variable pieces go away, because the whole problem with both equations is there's too many variables. The number of variables in each equation is too damn high. So elimination is beautiful. It just says, let's kill one of them. All right, I like it. I don't condone killing outside of algebra, everybody. So don't go kill somebody. Say, my teacher said to do it. I don't like you. All right, now I promised I would show you the other way. So I'm going to erase this. Has everybody got what they want from this? So I'm going to
Yes,
get the
sir.
same answer. Oh, sorry.
Yes, you can erase it.
All right, I think so. Here we go. All right. So to do it, substitution, this seems like it's not set up for substitution, but can't I solve this second equation for C? Now I know C is this. So then I can take the first equation and rewrite it. 3 H's plus 2 C's. But what the hell is C? 7 minus 4H equals 650. So if I solve one of them for a letter, I can then plug that into the other one, because now I know that C is this. So let me put it in there. And what does that accomplish? There's only one letter now. I can solve for it. So this is a very subversive way to eliminate a letter. 3H minus 8H is negative 5H. I can subtract 14 from both sides. And again, I get my negative 750. So of course I get my 150. Is everybody sort of with me?
I like this way.
Yeah, okay, good. I love it. Fine. Either way will work. It's just that substitution. Do you realize that if I put a 5 here or something, and can you solve for C nicely? No, you would get a bunch of fractions, right? But if one of the variables has no coefficient, substitution will always work pretty well. So then C would be 7 minus 4 times $1.50, which again is 1. So $1 for a Coke. Same answer we got before. So that's the substitution method. And with the first one we did was the elimination method. Both ways work.
Thank you, Professor.
What? Okay. This is why I need to remember. Everything gets thrown off for me a little bit being on frickin' Zoom. But I don't think I had a large enough talk about homework with you guys. For example, don't let it be a week between when we lecture something and the first time you look at the homework for that thing. Because then you're gonna be like, I don't remember talking about this shit at all. Damn. And you don't have all the time in the world to go back and rewatch the whole lecture on YouTube, even though they're up there for you. But if I were you, the minute I get time after class, I would try a couple problems out from what we talked about, no matter where I am in the homework. And then I go back and finish wherever I am. But I do a couple just to keep it in my brain. Otherwise, you forget all about it. I understand that. There's no reason for it to stay in your brain if you don't use it. Okay. Anything else while I'm up here? Okay. All right. If you joined, oh shit, somebody just left. If you joined late, the quiz has been moved to tomorrow. So it's not going to be today. So it'll be due on Friday. All right. Whoa. So let's see. Let me, oh, you guys are way over there. Anything else, guys, from homework stuff? Okay. So let's just talk a quick review of what we've done so far in chapter 4. 401 was about inductive and deductive reasoning. And I think we talked yesterday about those. We had a little review of those yesterday. But basically, one kind of problem I really like to give is either one of these visual kind of problems or a problem like, tell me what the next number is in this sequence, right? We did examples like that, I think yesterday. Remember that? Maybe. There's a really kick-ass, now watch this. Let me show you this right now. There's a really kick-ass sequence. Oops, somebody's chatting at me. Damn it. Oh, okay, you're fine. So let me carve out a little section for myself. This has nothing to do with that problem up there. We talked about Pascal's triangle, remember? Look at this sequence. I don't think I've talked about this yet, have I? Does that look familiar to anybody? I did talk about this?
Yeah, we
Sounds
did.
like me. Oh, sweet. All right.
I think you talked about it.
I can't talk too much about Fibonacci, so. Oh, yeah, I remember. I made this stupid joke about Fibonaccios. Yeah, look that up sometime. So that's a really good example of a very strange way to build a sequence. And it feels like somebody just playing around. They're just bored. Well, let me write 1 and 1, and then 1 plus 1 is 2, and then 1 plus 2 is 3, and then 2 plus 3 is 5. Damn it. When are they going to call me up to the DMV desk? 3 and 5 is, all right. But it ends up having applications in almost every field on Earth. It's crazy, right? So you can look up Fibonacci finance, Fibonacci art, Fibonacci music, Fibonacci whatever. And there, I almost guarantee that there's a connection. Okay, we clear that away. So that was 401, was about reasoning, really finding patterns, which is the most fundamental thing math does. And then 4.2 is where we talked about distance formula, which is really just an application of Pythagorean theorem. Do you guys remember? We opened up with a quote from John Bon Jovi for some reason. I have no idea. I didn't read that. Thank you. So there's the good old Pythagorean theorem. Most of you guys kind of know that. And then the distance formula looks different, but it's actually just a direct application of Pythagorean theorem. Okay. Do you guys have to remember this? Yes. Ha 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 ha. I like it. And then 4.3, we talked about margin of error. That's going to be on the quiz that's after this quiz tomorrow. So this is not anytime soon, but just to remind you guys, this is all built on, let me see, where do they give you the formula? Here, it's built on this formula, and we made this formula a little bit better. I asked you this before, but what do we call 1 minus b hat?
Q hat.
1 subtract P.
I love you guys. That was was that in stereo? That kicks ass. Yeah, Q hat. We call it Q hat. And what's it mean when it's wearing a little hat? It means it came from a sample. I like it. The good old P hat. It's the hat you don't want to wear. I think 4-4 was, yeah, we skipped 4-4. You're welcome. And then 4-5 is what we did. Well, we've been working on for a while, the exponential stuff, right? The exponential models. And we've talked about exponential versus linear before. So some of this is repetitive. It's the same idea. Remember dividing these to see how much it's actually growing by? We've done that before. Okay. And then I think the next section is another one that I threw out because it's not something that we necessarily have to do. Which is unfortunate because this is where we talk about exponential decay, which gets nifty. Like how long will it be until the area around Chernobyl is habitable? A long time. Chernobyl is more than just a horror movie. So let me see. All right, so this is where we haven't even gotten into yet, this section here. And I got a nifty video to show you guys today. We're going to watch a little tiny, very short video. It's not going to be like for the whole class. Like, anyway, whenever you watched a video for the whole class in high school, it probably meant your teacher was hungover from the night before. So they just needed to like relax. Okay. So the whole idea with this section is finally living up to the title of this chapter, living in a nonlinear world. We're getting into nonlinear equations. Parabolic is our first type of linear equation. So we're going to slowly build up to it. Let's see. Oh, please. Who cares? All right. So, I mean, has anybody ever played Angry Birds? So, you can pull the sucker back and you can change the angle and it sort of gives you that arc that it's going to follow, right? So you could do like an arc like this and maybe hit here. Is that going to be good? If you make too high of an arc, you'll just miss everybody and they'll laugh at you. And I guess they have to make these. I have no idea what these are supposed to be. They look like M&Ms. What the hell are those supposed to be? Anyway, they're trying not to infringe on any copyrights. Go ahead, sir. Do you have a suggestion? Food? No. What'd you say?
Poop.
If you like to consider that they're little pellets of poop, sure, you can do that. Don't know why we're shooting birds at poop on wooden boards, but whatever you want to spend your time doing. This, of course, is an example of parabolic motion of a ball. Let me see. Which part of this do I want to do? Nah, screw that. Here we go. Perfect. All right. So look at this problem. We're going to build this play area for this guy's dog. His name is Moose, Mickey Mouse. Since he wants Moose to have plenty of room for chasing squirrels, he decides to use all 160 feet of fencing. Now, this is something we can do right now. This is nothing new. Look at number 1 and try to come up with the answer for this. He's using 160 feet of fencing. If he makes the width 5 feet, what would the length be? Don't say anything out loud. Just think about it. This is the time to try whatever the hell you want to, because I'm not going to look at it. I'm not going to grade it. Don't worry about this answer with a full sentence bullshit. Right? Just figure out what the answer is. All right, let's see. So they're saying if they make this 5, what would this be? Right? That's the question. So what I would do is I would say, okay, there's 5 over there also, right? So what approach are you guys taking? Can somebody tell me what you're doing? Not what the answer is, but just what you're trying to do. Anybody?
Subtract 10 or subtract 160 from 10. Subtract
I
10
understand.
from 160 and then divide it by 2.
I like it. So the physical idea of what Cameron's saying is if I put 5 feet there and 5 feet of fencing there, how much do I have left? Well, let me put this down here. I have minus, so I've used 10 feet so far, so I've got 150 feet of fencing, right? Left. And I've got to put that here and here. So then to figure out what the length is, I would take 150 divided by 2 because I have 2 places to put it. Is that effectively what other people are doing also? There are a couple of different ways you could do this, but this is the primary way. All right, so you get that that's going to be 75. What was this, feet? And let's check it. Does that answer make sense? Well, yeah, because 75 plus 5 is 80. 75 plus 5 is still 80. And then 80 and 80 is 160. Check. So let's review what we had to do. You had to take 160 minus twice the width divided by 2 to get the length, right? That's what you did. And this is the way that we're not used to thinking because we don't normally, we tackle a problem as it comes at us. Math says, wouldn't it be great to capture what you did? So if you have to do the same kind of problem later with different numbers, you can just look at what you did before and not have to start all over again. That's basically what math fundamentally does. All right. Maybe. All right, let me clear this so I can move forward. I got to figure out a better way to do this so I don't have to clear my drawings every time. Here it goes. It's going to go away. Bye. Now, here's what would the length be if the play area is 50 feet wide? So now you should be able to do this pretty quickly. So let me draw this again for you. So what if this is 50 and I still have 160, holy shit, I still have 160 feet total.
30.
Now you should be able, all right, that was pretty quick. Yeah, right? You just, because we've already figured out how to do it. 160 minus 250s divided by 2. Isn't that the idea? 160 feet minus, because if I use 50 on each side, that leaves me with 160 minus 250. So it leaves me with 60 divided by 2 is 30. Exactly. I like it. So in general, if I'm given the perimeter, let me see if I can push this a little bit. Which part of this was the perimeter? Which number?
160.
160. That was all the way around. That's the fencing all the way around, right? So perimeter minus twice, and this was the width. I have no idea why I put those parentheses there. Let me get rid of them. They're bugging me. Go away. All right. Perimeter minus twice W divided by 2 would give me L. And of course, that makes complete sense. Let me do something else over here. Why does that equation that we just wrote down, or I did, make sense? Because what's the perimeter of something with a width and a length? My God, what is that? I'm going to leave that there because it's such a beautiful little thing. So the perimeter for something like this is 2 widths and 2 lengths, right? How do you solve for L? I'm going to subtract 2W. And then I divide by 2. Well, isn't that what we did? I really want you guys to see that. We could have known ahead of time the shortcut way if we would have just started with the actual perimeter formula and solved for the length, because that's really what we're doing in those first two problems. Is everybody at least mostly with me? All right, maybe.
Basically solve what you're looking for. Okay. Right?
Yeah, exactly. If I know the general relationship between everything involved, which means an equation, I can then solve for the specific thing I want. And then I have a general way to do it no matter what the shit I make the width, right?
Right.
5, 50. So of course now in number 3, this will be semi easy. I think I can't quite see all of it, but it doesn't really matter. So if the width is 5, we already figured out in number 1 what the length was going to be, right? Does somebody remember what that was?
$75.
35. Thanks, kids. All right. And to be honest, there's a quicker way to figure out what the length will be. What is 75 plus 5?
80.
No way. And why does that make sense? The length, if twice the length plus twice the width has to be 160. Is everybody with me? That's true for this rectangle because he's going to use all the fencing for the perimeter. Is everybody with me? What does L plus W have to equal?
80.
80. So that's a really good quick. So if that's 10, what's this going to be?
70.
70. I have no idea why there's a little. Let me make sure you guys know this is not a decimal. Oh shit, what did I just do? Okay. Get out of there. Ah shit. My 7 is naked. Bam, there he is. So this will be 70. Now, before I get too far, what's the area here? So what do I have to do with these now to get the area?
Multiply them.
Multiply them. So what's 5 times 75?
37.5.
375, I love it. So the ordered pair here would be with area. It would be 5. So with the 5 ends up with an area of 375. I like it. So you guys go ahead, finish that chart out. I'll just sit here and do nothing. Maybe I'll do something. Here we go. Okay. I mean, look how much that changed. You guys doing all right out there? Get in there. What do you notice once you get past 40?
It just goes back the other way.
Yeah, it starts going right back the way it came up here, right? And of course, that makes sense. We know that's what parabolic stuff does. We're going to talk in a minute, why does this end up being a parabola? We'll talk about that in a minute. A parabola. Not just one bola, but a parabola. All right, so I'm not even going to worry about the rest of this. Blah, blah. There's an 80 down there. Who cares? So just looking at the results, what dimensions lead to the largest area for my dog Moose?
40 by 40.
All right. I like it. So that's always true. If I have a rectangular shape, the way to make the area the biggest and keep the perimeter the same is to make it a square. This is little s's, sorry, for like side lengths. So that's a little square, right? And because imagine if I make the width 1, that'll make the length freaking, I forgot now, what was it? Oh, 160. So that'll make the length 79. And the area would just be 79 square feet, right? So the smaller one dimension is, the smaller the area will be, which means it makes sense then that the biggest the area can be is if they're both equal. Because the smaller one gets, the smaller the area gets. So if they're both equal to each other, that'll be the highest. So let's graph this bad boy. What kind of, so we're graphing these points. What kind of scale am I going to need here? And this, of course, down here will be width. What kind of scale do I need for my area? How far up do I have to get? What's
16.
the highest I got?
1600.
1600. I like it. So if we do 2, 4, 6, 8, 10, 12, hey, that works.
Perfect.
We'll make this, yeah, sorry?
No, I'm saying perfect. Perfect. 2.6.
Yeah, it works out. There's nothing wrong with taking a guess on a scale and then trying it and then going, well, that didn't work, and then picking something else. And down here for this scale, it looks like a really good scale for the x-axis, for the width axis. I just have to be able to go up to 40. So let's see, 5, 10, 15, 20, 25, 30, 35. Yeah, that'll work. All right, so if I plot these real quick, where am I at? 5 goes to 75. So that's like, this is 100 in the middle. So 75 will be like right there. Oh shit, what am I doing? 375, Jeff. Yay, Jeff can read. Get out of there. 5 goes to 375. That's my bad. 10 goes to, so I'm looking at these here. 10 goes to 700. So it's right in the middle of 6 and 800. 20 goes to 1200. Where am I at? 30 goes to 1500. Oh, I guess that's funny, Jeff. I didn't, I could have made this scale better, but all I want to get to is the highest point. So that's why I just picked 40, it looks like. Where am I at? 30 goes to 1500 and 40 goes to 1600. And then I would have like, it would start to come back down over here. So it goes. And then it just repeats itself. That's why I don't care about this side. It just repeats itself. So that is definitely the highest point. Does anyone know what that point is called on a parabola?
No.
So that point right, that little point right in the middle, that point there, do you guys know what that point is called? Starts with a V.
A vector?
I like that.
Vertex?
Vertex. I like it. Vectors are actually what I'm talking about with my other class right now. Little vector living in space. Oh, look at the little vector. Go away. All right. right, so let's talk about why did this problem end up being parabolic? Let's talk about that next. I'm gonna clear all this. Is everybody ready for that? I'm gonna clear this away. It's going away. By work. By work. Okay. Blah 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 blah. Okay. So look at number 8. Let me see. Let me fit some more stuff on here. Yeah. Okay. We basically already did this. Write an expression with W representing the width to describe the length when the width is W. Okay, they take a long time. So remember, we already did that. We did L equals P minus 2W divided by 2. In which case, I can be more specific. For this specific problem, it was 160 minus 2W divided by 2, right? Become a W. That's the problem. That's the one we just came up with earlier. And then we get it. And then I showed you an even better way. Be really careful what I'm about to do here. I can't just say 160 divided by 2 is 80 and then put minus 2W. That's wrong. That's very wrong. That's very, very wrong. What's being divided by 2 in this problem is both 160 and 2W. So that becomes 80 and that becomes W. All right, let me stop for a minute. Isn't that the shortcut we came up with to figure out what the length was given a width? So that's the algebra behind that realization. Now this number 9 is kind of dumb. These are the kind of questions that you guys do too much for. What's the area formula for a rectangle? L times W. Okay, I'm not even gonna wait for anybody to answer me. That's all number 9 wanted. But now look, what is, I don't know why I'm using different symbols for L, but I just am, but so just deal with it. What is L? What is L?
80.
No.
80 minus W.
80 minus W. So this is the idea of substitution. So in place of L, I'm going to put 80 minus W, and then it's times W, right? L times W. Can you simplify that for me? What do I have to do to simplify this? I just have to take this W and multiply it in. Is that cool? Distribution? I get 80W minus, what's W times W?
2W.
Careful. Right? 2W would be W plus W. W times W is W squared. And that is quadratic. That has a highest power of 2. We would technically call it degree 2. And thus, its graph is supposed to look like a parabola, like we just got. I know it's parabola. I just like to say the. So that is the algebra behind the fact that the picture we got makes sense. We got a parabola. In fact, we can be more specific. Wasn't it a down parabola that we got? Why was it down? Because that's negative. If the W squared term is negative, it's going to be a down parabola. It's going to be a sad parabola. If it's positive, it's going to be a happy parabola. All right, I like it. I know that's dumb. I don't care. All right, maybe. So somebody, can you look up on your chart? Do you remember when W was 5? I think we got 375 for the area, right? right?
Yeah, it was
Okay.
375.
So let's try this formula out. Area equals 80 times width minus width squared. It better freaking come out to be 375. I'm going to throw all this shit out and we're going to forget about the rest of the semester. This is where I get really kind of nervous that I make a stupid mistake doing this. So 80 times 5 is 400. I think I'll be okay. Area is 375 square feet. Check. So this formula captures all the work we did in a much more concise way. Because we basically did all this work, but we did it for each new width. This formula just says, screw all that, dude. Holy oh, Jeff. Listen up, kids. If you know the width, you can figure out what the area would be just in this one easy step. All right. Maybe. I really want to get to the point. I want to show you this video because it's kind of interesting. All right, I'm going to clear all this away. How's everybody with that? You guys ready? All right, here it goes. All of it's going away. Bye. All right, I think that's, yeah, let's look at this one thing here. So this is kind of a little bit strange, but you've got this electricity being generated by this company, this power company. This is their profit if they make so much energy. So most profit functions at least look somewhere like this. Now, the more complicated your finances are, the weirder your profit function will look. But there should be these little hills. So obviously, where does the company want to be on this graph? Do they want to be over here? Do they want to be there?
They want to be at the top of the hill.
Shit, yeah. So then what the one of my best friends, he's a financial analyst and he makes shit tons of money. But what he effectively does is he puts together equations that model the profit based on all these different variables. And he tells the company what price to set things at. That's one of the things he does, but it's a huge part of his job. So it's always trying to figure out, where is that hill now that this has changed in the economy and this costs this much now and people feel like this? What does our graph look like now and what should we be trying to get to? Do you guys sort of follow me? So, and again, that's most of the time, that is the most important spot on a parabola, is that vertex. Because in this case, it means max profit. Oh yeah, money. So again, what do you think the y-intercept tells you? What is the y-intercept of this roughly?
Looks like it's around 0, negative 47 or 48,000.
And be careful, that would be up here.
Oh,
It's even
sorry.
more negative, yeah. So
60.
going the other way. So I agree with you though. It's like maybe, I'd say negative 60,000 or 65,000, somewhere around there, right? I don't know why I wrote 1,000. It would have been quicker to write the zeros. So what does that kind of correlate to business problems we've talked about before?
Overhead.
Yes, overhead, just to set up their electricity generating equipment, right? And then they start to generate and sell some electricity. And then there's a sweet spot right there, because if they go past that, there's not enough demand. They're over generating electricity and wasting resources to do it. And that's why their profit goes down. So, it kind of makes sense. All right. Did we have to know all that for this problem? No, but I'd just like to point out the visualization of the algebra, the graph that we create, we can get immediate idea of several physical things happening. All right. So let me do this. I think I've already answered a few of their other questions down here. Who cares? Blah, blah. Yeah, we did it. All right. So let me show you this. We're going to get to this in a minute. I'm going to show you this video. I'm going to have to stop recording because otherwise YouTube is going to get angry when I try to post this later. So recording anymore. Start it back up. Do you guys understand so far? I mean, that's so to make a dartboard using this mathematics and those that technology he's got is sort of frivolous and sort of silly, but it actually tests the algorithms he's using. And then you can use those same ideas in something more practical, right? Something else that needs to be able to catch something or stop something from hitting somebody else or something, right? Do you guys kind of follow what I'm saying? So I love that video because it doesn't get crazy technical. He's about to get into the part of exactly what computer components he used and all that. So I didn't want to make you go through that. But if you're interested in that part, you could just let me know. I can tell you what the link is. Let me think. What else did I want to say about that? I forgot. All right. Well, I think that's good. So let's come back to the book, unless anybody has anything else they want to say. Like it. Let me see.
Yeah, let me see. What about the inverse of that? Instead of a moving object. So let's say shooting, right? Would the math be the same? I mean, of course it would be, but I don't know what
Yeah, it would be very similar. Are you talking about, so here's what I'm talking about with the missiles. So it's like your dartboard is actually moving. And the dartboard calculates the trajectory. So it's not a dartboard anymore. It's an interceptor missile, but it calculates the trajectory of this thing coming, and then it changes its trajectory. Sort of like the dartboard moved up and down, left and right. I think that's sort of what you're asking, right?
Right, because here the target is moving. Yeah, target. You adjust the target to move to adjust toward the ballistic. So like in say in shooting a rifle, you have to adjust yourself. You know what I mean?
Oh, I see. Yeah. So you could use something similar to like if you have a gun set inside of something and it moves.
Right.
Moves, yes. You could do something it wouldn't take a lot of changes to the algorithm to do that. Because a lot of the physics behind this doesn't care which thing is actually moving.
Okay.
I don't know, that's getting a little too off topic, but yes, I like it, yes.
I think that guy's wasting his talent. I just have to say. It sounds like he should be doing something. I'm just saying, sounds like he's wasting his talent.
Listen, guys. Listen. All right. Do you know about making like a scale model of something before you create the whole thing, right? You guys with me?
Mm-hmm.
Why do you do that? Because you want to make sure that it's going to look the way you want it to. You can actually build it with the same kind of materials and test some structural integrity stuff. You can do a lot of little things before you make the big thing. Like I said, this algorithm he created that his computer uses to calculate these things can then be modified and used in other more practical situations. So this is sort of like building a scale model, building something interesting that you can then show to people. But behind the scenes, you're testing an algorithm and seeing how effective it is.
So
again,
yeah,
okay.
Excuse me.
Go ahead.
So basically, mathematically, he's showing that that you can, like you say, for example, a missile or whatever it may be, something more practical, that mathematically you can pretty much predict.
Yes.
According to the, in mathematical form, basically, you do something more practical with it. Yeah.
So obviously the military already has computer programs and stuff that do this, but I'm not saying his purpose is to try to improve those systems. He probably has, he's probably not wanting to necessarily do anything for the military, but that's a great way to test your computer program. That's a great way to test how effective it is and your setup. And then you could try to do that in some other situation. Anyway, okay, that's enough of that. So you guys get the basic premise. I agree with you. That was kind of a silly use of that. But at the same time, I want you to understand that's sort of like building a scale model of something. It's very similar. Okay. So coming back to this real quick, let me see. Last thing I want to say, and last thing I want to point out is this. This is the general equation of any quadratic function, any parabolic function, a function that would end up being a parabola if you graphed it, right? Can somebody figure out, I will tell you this, 2 of these are not parabolic, are not quadratic. 2 of these are not quadratic. Like, look at the first one. Look at part A. Can somebody tell me what A, B, and C are, comparing it? Or, yeah, I am sharing. Thank God. The other day, I was talking for like a full minute, saying what I'm saying, and then somebody finally said, "You're not sharing the book." I'm like, holy shit. So looking at this function here, and I am sharing the book, right? Please tell me, anybody. Can somebody tell me what A, B, and C are here? Am I sharing the book?
Yes, you're sharing the book.
Thank you. Okay. So looking at this function here, that's where A, B, and C are. Can you tell me what A, B, and C are for this guy? What's A? Do you guys see? Here's the form.
4, 16, 3.
4.
Yeah, 4 is A, 16 is B, -3 is C. Right? It's just like MX plus B. You just read off the things when they're in the right place. What about part B? Is that quadratic?
No.
No.
Why do you say that? It's okay to have, look at what it say up here. B and C can be 0.
Oh.
So can somebody tell me, I will tell you this, it is quadratic. It is. Can somebody tell me what the value of A is for this guy?
X
8.
squared.
8.
Careful.
No. Value for A is 2. Is
Like
x2
1.
x squared.
So not x squared. A is the number in front of x squared. And it's not 1. It's not 1.
Negative.
It's -1. Kick ass. I really want you guys to see that. So the answer to what A, B, and C are will never include the letter X because these are numbers. So A is the number in front of the x squared. So A is -1. B is the number in front of the X. So what's B?
8.
8. C is the number by itself. Well, what's C? 0. What's wrong with this guy? Why is he not quadratic?
Because there's a cubed.
Yeah, it's a freaking cube that gets way too big, man. I just need a square that's the biggest. What about D? I'm telling you, D is quadratic. Why?
Because the x and x make it squared.
Yeah, dude. 2x squared minus 8x. So then A is 2, B is -8, and C is 0. Is that all right? You guys see that? Anybody realize what's wrong with E? E's not quadratic.
Square root.
Square root.
Yeah, stupid square roots. Not allowed to have a square root in there. It's got to have something x squared, and then maybe something x, and then maybe a number. So what about this? Is this quadratic?
Yes.
Yes, because then B and C are both 0. That's fine. B and C can be 0, but A can't be, because A is what makes it quadratic, the fact that there's a squared variable. Okay, I like it. I think that's enough for today, right there. That's enough. We've done plenty. All right, let me know if you need to hang out afterwards. Don't worry about the quiz today. It's tomorrow. So focus on getting your homework at least through 4.2. done. And I will try to carve out some time today to grade some more of your homework. Cool. All right, let me know if you need to hang up. Sure.
Bye.
It's just homework related, but if you're gonna do that at a different time, it's fine.
What do you got?
Page 501. Number 1. So I'm thinking to just,
Oh, okay.
so what, F just
So we-
equal
yeah.
K times A?
That'll work.
That'll work?
And I would use, and that works. So you're saying X is force.
F is
directly-
force.
Sorry?
I was gonna write F equals K times A, acceleration.
I love it. That's better. I thought you said X instead of F, but F equals
F.
K times A. That's perfect.
That's all they wanted?
That's it.
Okay.
And to be honest, in physics, you learn that the K is actually the mass. So you get F equals ma, force equals mass times acceleration, but you don't, that's extra information you don't need. Yep.
Okay, all right, thank you.
Welcome.
Jeff, which one of those are of the homeworks are did you count out? I know 4, 6 was one, right? Which one was the 4, 4?
Here, let me show you. Where are you? There you are. So on the updated homework sheet, 4, 4 is out, 4, 6 is out, and 4, 11 will also be out. Yeah.
Okay.
Cool.
I can go right on over. I can go to my to the canvas and see all that.
Yes. And like I said, this one is.
How do you do that? What do you?
Homework timeline sheet right there.
Oh, okay.
So when you go to 96, go to homework timeline sheet, kabam. And of course, the quiz date is now tomorrow, the 19th. Of course.
Mañana.
So,
Yeah.
yeah. Okay.
Cool. Thanks.
Sure. Everybody else all right? What's up? Are you guys actually out there? All right. I'm going to head out. I don't see anybody needing help. So I'll see you guys later.